Hi, my name is John Paulraj and I'm on a mission to make the learning of math fun. This is part 4 of Algebra of Inverse Functions. So if you missed out any of the earlier parts, I will link them in the description below. Please be sure to check them out. On this video, we're going to discuss the inverses of exponential and logarithmic functions. So let's go. When we hear the words exponential and logarithmic functions, we say, well, they are inverses of each other. What's that to even explore? But if you just step outside of the rules will not change. I'm not saying we're going to change the rules or something like that. But if you just step outside of the rules, the procedure, I can assure you that there's something that will be worth appreciating. So this is our first question. This is an exponential function. It's a transformed exponential function. So first, before we take those rules to find the inverse, let's just look at this exponential function and see what has happened. How has it transformed? The first thing that we can note is that, well, there is a horizontal shift, a translation, okay, a horizontal shift by 3 units. Okay, and if you want to be specific, you can say to the right. So this function, this exponential function from its parent exponential function is actually shifted to the right horizontally by 3 units. Then what has happened? What's the other thing that has happened? Well, there's a vertical shift up. Okay, so there's a vertical shift by 2 units. And we can also say that's up. So this is the transformation that this function has gone through from its parent function, the original parent function. Now, let's write down the domain and the range of this function quickly. The domain of this function is going to be all real numbers. For every exponential function, you know that the domain is going to be all real numbers. The range of this function is going to be from that horizontal asymptote. You know that y is equal to 2 is going to be the horizontal asymptote of this. Just make sure that I mention that also. That's the horizontal asymptote at y equals 2, so that the range of this function would not include 2 and will go all the way up till infinity, okay? Increasing that way. Now let's do the procedure of interchanging x and y. And we'll first write, okay, x interchanging y, x and y being interchanged. So you can write the equation as x is equal to 3 to the power of y minus 3 plus 2, okay? Now, let's do our algebra. We need to make y the subject of the formula, right? So let's do our algebra. This will give you x minus 2 is equal to 3 to the power of y minus 3. And now from the exponential form, we can write it in the log form and say that the log to the base 3 of x minus 2 must be equal to y minus 3. And the same thing can be written as y is equal to log base 3 x minus 2 and a plus 3. This new y that we have found out is going to be the inverse of the function that we were exploring. And so the inverse of the function can be written as x log to the base 3 x minus 2 plus 3. Now, just as we examine the transformations of this original exponential function, let's examine the transformation of this logarithm function, how it has transformed from the parent function, the parent log function. Okay, so when we look at it, we can see that, all right, there is a horizontal shift, all right? There is a horizontal shift to the right by 2 units. Okay, you can see that. And then there is a vertical shift up by 3 units. All right, I'm just making sure that it's in the view of the cameras. And this graph is also going to have a vertical asymptote at x is equal to 2, all right? The domain of this function, the domain of the inverse, would will be from 2 to infinity, all right? You can see that, okay? And the range of this function, the inverse function, is going to be from negative infinity to infinity, okay? Now, if you were to compare, now we've already done the comparison of domain and range earlier on. If you compare, the domain has become the range. You can see the range of the log function was negative infinity to infinity, and the domain was from 2 to infinity. Is that right? Yes, the domain of the inverse is 2 to infinity. But let's examine the transformation. The inverse function has a horizontal shift to the right by 2 units. And when we look at our original function, the 2 units accounted for a vertical shift and it's going up. I want you to note this very carefully, okay? The original function has a vertical shift of 2 units going up. And the inverse, its inverse, has a horizontal shift going right by the same 2 units. And the inverse function has a vertical shift going up by 3 units, whereas the original function has a horizontal shift going to the right by 3 units. What does that mean? Let's take a closer look. Where the original function has a horizontal shift, the inverse function is going to have a vertical shift. Same units. Horizontal shift, we saw that it has by 3 units. The inverse function, vertical shift by 3 units. Can you see that? And where the original function had a vertical shift by 2 units, vertical shift by 2 units, the inverse function has a horizontal shift by 2 units. Do you see that? Can you see that? Okay. Now, here's something very important. Watch this carefully. Where the function had a horizontal shift by 3 units, we had the inverse having a vertical shift by 3 units. But it was a horizontal shift to the right, that is positive. We have a vertical shift up, positive, positive, positive. And that means that if the original function is increasing, well, we might be tempted to say that, oh, if that's increasing, the inverse must be decreasing because everything else gets reversed. But as we can see, even in the graph, the blue graph is the graph of the function. We started off with the exponential function, 3 to the power of x minus 3 plus 2. The green graph is the graph of the inverse function, log to the base 3, x minus 2 plus 3. And you can see that the blue graph is increasing. The green graph is also increasing. Yes, where the blue graph has a horizontal asymptote at y equals 2, the green graph, the inverse, has a vertical asymptote at x equals 2. See, those things are getting interchanged and reversed if you were to think like that. But the blue graph is increasing and so is the green graph. The function is increasing and so is its inverse. Next example. This next function is a log function, a transformed log function. We saw a transformed exponential function earlier on, and now we're looking for the inverse of a transformed log function. But instead of taking the normal path of interchanging x and y and finding the inverse, we're doing things slightly differently. Bear with me, you are going to find this interesting. Okay, so again, what I want to do right now is that I'm just going to write down the transformation of this function. Okay, so to do that, first I need to just factor out the term inside, and I can write the same y as 2 ln of, I factor out 3, and I can write this as x plus 2 in the inner parentheses, and that 2 means that there's going to be a vertical stretch of 2. Yes, it's clear. And then this 3 gives us a horizontal shrink of 103. Okay, vertical stretch of 2. That's this factor accounts for the vertical stretch, and then this factor 3 accounts for the horizontal shrinking by 1/3. All right. Then we also have a horizontal shift, but this time to the left. Okay, so I'm going to write that down. A horizontal shift by 2 units to the left. All right. So these are the transformations of the original function. What we're going to do is that using this information, we'll try and see whether we can predict the transformations of the inverse functions. Bear with me, this is going to be fun. All right. So let's see what's going to happen. Vertical stretch of 2. That means there's going to be a horizontal stretch. Stretch will remain stretch of 2. Okay. Vertical stretch of 2. That means the inverse now is going to have a horizontal stretch of 2. That's our prediction. There's a horizontal shrink. Oops. There's a horizontal shrink of 1/3. Means we are going to have in the inverse, we're going to have a vertical shrink of 1/3. Okay. Notice what's happening. Okay. Where there is a stretch, we're keeping it as a stretch. Where there's a shrink, it remains as a shrink. That's what I was saying earlier on. Okay. Certain behaviors. All right. Where there's a 2, that remains 2. 1/3, 1/3. What's changing is vertical, horizontal, x's, y's. Just pay attention to those commonalities, all right? Now the third one, horizontal shift by 2. So we are going to have a vertical shift by 2. All that is great, except here. It's going to the left. That's the horizontal, right? Left. Left is negative. And if it has to be a negative unit along the vertical, it must go down. Okay, I hope all this is clear. Okay, so this is going to be our predicted transformation for the inverse function, okay? And let's see what happens. So now let's go back to our algebra, do the interchange and figure out what the inverse is and then verify whether all these transformations are actually true, all right? Here we go. So my function was y is equal to 2 ln 3x plus 6, okay? I'm going to write that thing down. Maybe I should write it on the side here. Can we see that? Y is, the original function was y is equal to 2 ln, was it ln or log? What was it? It was just ln, okay. Y is equal to 2 ln, then we had a 3x plus 6. Is that correct? Let me make sure that I've got it right. 3x plus 6. Okay, cool. First thing, interchange x and y. Okay, we got interchanging x and y. So we'll have x is equal to 2 ln into brackets 3y plus 6. And now we need to make y the subject of the formula. So in order to do that, let's write this as x over 2 is equal to ln of 3y plus 6. Okay. Now if you say this is e to the power of x over 2, that must be 3y plus 6. Can you see this? All right. And we'll have, I'm going to write 3y is equal to e to the power of x over 2 minus 6. Cool. And then I can say y must be equal to e to the power of x by 2. There's a 1/3 minus 2. All right. And this new y is going to be our inverse. So we write f inverse x is going to be a third e to the power of x by 2 minus 2. This is our inverse function, but let's try and see what we predicted about the transformations, how far they are correct. When we look at the inverse function, we can see that there is a vertical shift down by 2 units. And as we had predicted here, can you see that? Vertical shift down by 2 units. That's good. Vertical shrink of 1/3. It looks like there's a 1/3 only for one term and not the other term. But if you look at the earlier stage, you had 3y is equal to e to the x by 2 minus 6. And that clearly means that, you could have written the same expression as y is equal to 1/3 of the entire expression, which is e to the x by 2 minus 6. And that would still mean that this 1/3 is a vertical shrink by 1/3. And that is correct. The third thing, or we are going the other way around, the first thing would have been horizontal stretch of 2. And that again, we have an e to the power of x by 2, which means there is a horizontal stretch by a factor of 2. So what did we do today? We saw that when we were examining inverse functions, exponential function and logarithmic functions are inverse functions. But there's something very beautiful that seems to be happening to the transformations also. If the function had a horizontal shift by h units, the inverse is going to have a vertical shift by that same h units. If that h units was happening towards the right, this h units will happen up. If the function had a vertical shift by say k units, its inverse is going to have a horizontal shift by that same k units. And if that vertical shift was happening down, the inverse would be shifting horizontally to the left. And then in example 2, we did something strange. We listed the transformations of the original logarithmic function, and then using that information, we just wrote down our prediction, what is going to happen to the inverse function. And then we checked and verified that using the interchanging x and y technique. And we also pointed out one very important thing. Where there's a stretch, the inverse will also have a stretch. If the function is moving to the right, meaning positive, its inverse will also move up, meaning if the original function is increasing, its inverse will also be increasing. So when we step outside of the procedure, interchanging x and y, making y the subject of the formula, this is just rules. And I'm not saying break the rules. I'm saying just once in a while, step outside and explore what's really going on. That's when we see the beauty of the algebra involved in finding inverse functions. My name is John Paulraj, and my mission in life is to make the learning of math fun.